Hello and welcome to our fourth video in the How to Arduino series. This one's going to be covering serial monitors. If for some reason you have missed the first three videos, there is a link in the description for the playlist as well as in the upper right hand corner underneath the eye. With that said, let's just jump right into it. Today we're talking about serial monitors. Wait, not that kind of serial. I mean, that is a serial monitor, but that's not really what we're talking about. Let's try this. I'm not even sure what that. It is a monitor with Captain Crunch's hat, but no, that's still not quite the serial monitor we're talking about. Yeah, let's just keep on going. That's more like it. So this is the serial monitor. It's not nearly as cool looking as the last couple of pictures, but it is a lot more functional. And also, here are our topics for today. We're going to go over what the serial monitor is. We're going to hello world, because that's just what you do. Then we're going to cover talking to the Arduino, and then we're going to affect the outside world. With that, let's just jump right into it. Here we are once again in the Arduino editor. You can see that we have a new program all set up for us to go ahead and write some code into. But first, since today's talking about the serial monitor, let me show you where that's at. In the upper right-hand corner here, you see a magnifying glass, and then when you hover over it, it says serial monitor. Click on that, and it brings up the serial monitor window. In a few minutes, I'll go over what all of the other buttons and everything does, but now we at least know where it's at. In order to make the serial monitor show something, first we have to turn on the serial connection. To do that, we type serial with a capital S. We're going to need to type that anytime we do anything serial. Then dot begin. Inside the parentheses, we're going to put 9600. 9600 is the baud rate we're going to be using. If you're not familiar with it, baud rate is the number of bits transmitted per second. So now that we've told the program that we're going to be using serial things, the next thing we need to do is use a serial thing. So to do that, we're going to type serial.print. And then open parentheses. Inside quotation marks, we're going to type the standard hello world. In programming, that's usually the first thing you learn to do, so we'll do it here too, why not? From there, we once again need to save it. Call it serial test, because I've already done this a couple times. Yes, I want to replace it. And here we go. It's compiling, and now we upload onto the Arduino. And bring up the serial monitor, and it says hello world. It says it a lot, and it says it on one line. It's not exactly great, so let's make it a little bit nicer. First of all, we don't need it to print continuously, so we'll put a delay. We'll do 1 second. Secondly, it's all on one line. I don't like sideways scrolling stuff, so instead of using print, we'll use println. Println is print line. So we'll put this just on one line. Let's take a look and make sure it works. Upload, bring up serial monitor. And every second brings up hello world. Good deal. So now let's go over what some of these things do. We'll start at the top here. COM8, that's the number of the COM port that you're using for the USB. If you don't realize it already, the S in USB stands for serial. It's the universal serial bus, and it's sending serial information from your Arduino to the computer. Underneath there, we have a box that we can type things into. This is a box. Next to that, we have a button that says send. When you type something in here and then push send, it sends it through the serial port to the Arduino. Next, we have the box where all the information is. We went over that before. Then under there, there's some check marks. It says auto scroll. That makes it so it stops automatically scrolling. If it's checked, it will scroll to keep the bottom thing at the bottom. So you see now it's ticking up and I've missed a bunch of information. Next to that, we have show timestamp. If you hit that, it puts up a timestamp so you can see when it came across. Good stuff. I'm going to take that off. Next to that, it says carriage return. That is what is entered when you hit send. So it will either send you can have it so it sends only the data, so there's no line ending. You have it send a new line, have it send a carriage return, or you can have it send a carriage return and a new line. Leave it at carriage return. Next to that, it says 9600 baud. That's the same value we have here. That's good, because if they're different values, I'll show you what happens. Let's say we had it at 38400 baud. We get gibberish. That's because they're communicating at different speeds. And when that happens, is getting different bits of information. The information doesn't make sense, and it comes up just as, garbled garbage. That's hard to say. So if you ever have this open and you're getting random values that make no sense, first check to make sure that you have your baud rate set correctly. This does not change the baud rate that's on the program. The program is standalone. This is already compiled and on the Arduino. This is exactly saying what the baud rate is that the COM port is listening for. It's important to make that distinction. Then the last thing on here is clear output, and that just clears the screen so you can see what's going on easier again. Those are the parts of the serial monitor. So now we've learned how the serial monitor works. Okay, what can we do with it? Well, we can print information out to the serial monitor so we can look at it later. That's helpful. But we also have the ability to send information to it. Like I just, this is information, right? And we send it to it. It doesn't do anything though, because our code's not doing it. So how would we get this to do something when we tell it to? Okay, let's work on that next. That sounds like a fun idea. So the first thing we're going to have to do is we're going to have to make a variable that the information the serial monitor receives will be put into. That is going to be a string. We haven't talked about strings before. What is a string? Well, this is a string. A string is a string of characters. So inside of that, it can be anything, right? Now, this is a way to write out a string without having a variable. But let's say we wanted to not do it that way. We could do string greeting equals hello world. So that sets our string to the phrase hello world, or the value hello world. So instead of saying hello world here, we could just take this out and use like any other variable, right? Put in greeting, upload it to our board, look inside of our serial monitor, and once again, it's saying hello world once a second. Now what we don't need to have this, right? We don't need to even have this anymore. We get rid of that. Just clear everything that we don't need anymore. But we do need a string. We need to have a string that's going to be the message that comes in through the serial monitor. So we will call it incoming, because it's the incoming message. So what do we do next? Well, how about this? Why don't we just pretend that I haven't been preparing for this video for the last 4 hours, and we'll think about how do you find this information? Where do you look in order to understand what's going on? So let's try that. We'll bring up Google. Everybody loves Google. We'll do a search. What we're going to search for is Arduino serial. There we go. So the first thing it brings us is Arduino serial reference. We'll click on it. This takes us to what is called the API. The API is basically the documentation for a programming language. In this case, it's Arduino. And you can see here that we're looking at this serial hardware, no, not hardware, what do they call it? Namespace. So we're looking at the serial namespace here. And it gives a description of it. It says for each board, which pins they are, where it's at, all those sorts of things. Lots of information if you want to read it. And then it shows you the different functions that are available inside of it. Now you see some of them that might look familiar. Here's serial.begin. The way that these are written is you type the name of the namespace, which is serial with a capital S, like we've been doing, and then you type a period and then the function that you're using. So anytime we do that, you realize that's a different namespace, and that's how it works. So we use serial.begin. And what's it do? Well, let's take a look, see what it says. It sets the data rate in bits per second, baud, for serial data transmission. bunch of other information. It does all the things I just said before. You can see the syntax. It's telling us how to use it. It's serial.begin with the speed inside of it. There's another one, serial.begin with speed and config. So it says config sets data, parity, and stop bits. So that way you can set it up with parity bits if you want. And then there's all your different options for how they're done. It tells you what the function returns, which in this case is nothing, and it gives you example code on how to use it. That's really kind of slick, right? So there's that for all of the different functions that are available. So we want to read from the Arduino, or from the serial, right? So let's take a look, and we have right here, read. What does it do? It reads incoming serial data. Sounds good. So we can come down here, it has example code. We'll score, right? So let's try to incorporate this example code into what we're doing. So I'm gonna move it to another screen so I can see what's going on a little bit easier. And then we'll just write down what they have. So we have inside setup, it has serial begin, we do that. Inside the loop, we have if serial.available. Have no idea what that does. We haven't looked at it yet, right? Then it is, they use incoming byte. We're not doing that. So we're going to call incoming equals serial.read. Okay, score. And then at the bottom of it, we will do serial.print. What are we going to say? You just typed. Now this is where it kind of is nice that you, if you remember, serial.print only has things show up on one line. So I can do this, close that, and then immediately on the next one, I can do another serial.print line. And then inside of that one, we're going to put our variable. So we're going to say income. So we're going to look at it. What is serial.available? Okay, well, let's bring the screen back over, take a look. So we have serial.available right here. You see I've changed almost nothing. What is that? Okay, well, let's take a look. Serial.available right there. Available. So look at it. Get the number of bytes available for reading from the serial port. So what happens is when you type something into the serial port, it sends it to the Arduino, or anytime anything is sent to the Arduino, it shows up, it goes into a buffer, the Arduino looks at it, and then if you call serial.available, the Arduino will look at it, and it will then tell you how many bytes are available. So every time you type this, it comes up with a number, that is the number of available bytes. Okay, cool, makes sense. So if we look at our code, it says if serial.available is greater than 0. So that's saying if there's any bytes possibly available, then do this. What we're doing then is we're setting our string that we set up earlier, incoming, to be serial.read, which we just saw said it grabs the first byte. I don't remember. It said something like that. So it grabs the stuff off of the serial buffer, and then we're going to use that and print it out. So let's take a look at it and see what it do. So upload. There shouldn't be any problems. I copied it from their stuff unless I typed something wrong. There we go. And we'll take a look. It's empty, it's supposed to be. And we type something. This is a test. And we get a lot of numbers. Okay. So what is that? Well, it's numbers, but why is it numbers? Okay. So we'll look back again, bring back our API, and we'll go and look at read one more time. It says reads the incoming serial data. Parameters is serial, we have that. Returns the first byte of incoming serial data. And it says your data type int. So what does that mean? It means that it looks at the serial bus, or sorry, I keep wanting to say bus. It looks in the serial buffer, and then it says, okay, I'm going to pull the first byte from that, and I'm going to bring it in as an integer. Remember, everything that's going across from the serial is just ones and zeros. It doesn't know what it is. It doesn't know that we typed the word test. All it knows is we just sent it a bunch of numbers, which ain't true. We send it a bunch of ones and zeros, and then it interprets that as numbers based off of this. So since this returns an integer, we don't want to return an integer. We were looking at the wrong place. So let's go back take a look again. So now we have other things, right? There's parse float, parse int. To parse something is to separate it. That's not quite what we want. Read bytes until read string. Hey, there we go. Let's take a look at that. Read string. So serial.readString reads characters from the serial buffer into a string. Function terminates if it times out. The next thing we need to look at is the parameters. Okay, so just serial, good deal. It returns a string. Hey, look at that. That's exactly what we wanted. It's almost like I looked it up before. So let's try that instead. So this one doesn't have an example code, but we can figure it out, right? Last time we did serial.read and it gave us an integer. We didn't want that, so we want serial.read string. Just that easy, right? Let's hope. Let's take a look at it. Uploading, bring up serial monitor. This is a test. You just typed, this is a test. Yeah, look at that. It worked with no E because I typed badly. Yeah. So it's working. That's awesome. So that is how you read information from the serial buffer. And then print it right back out. Next, we're going to write a program that not only will read information from the serial buffer, but will then use that inside of the code to do something that we tell it to. So for this next program, what we'll do is we'll use the serial monitor to control LEDs. That way we're actually having the computer control something in the physical world, which is kind of a cool thing, I think. So this is the schematic for our next circuit. It's just a red and a green LED tied to pins 7 and 6 respectively. And then both of them are then attached to ground. Very simple circuit. Now that that's done, we'll just come through and we'll change our existing code. Why not? We already have it written. So we will get rid of these print statements. We don't need those. Okay. Then we're going to need to set up our lights. So come up here. I like to put my constants above everything else. So constant red equals 7. Constant green equals 6. So those are our pin numbers. As always, we just set up our pins. So pin mode, red, output. Pin mode, green, output. So now our pins are set up so we can turn on the LEDs. And that just leaves us with actually doing something with our red serial value, which is a string as we decided before. So inside the loop, we're going to collect the string if it's available. Then after that's finished, what we will do is we will check to see if it matches. Well, let's just call them red and green, make it easier. So we'll say if. Now this is where things get a little different than what we're used to. Strings are a little funky. The first thing you would think is we'd want to go if incoming is equal to whatever, right? This logically makes sense, but in Arduino, this does not work. It has to do with the way the strings are written, a little outside the scope of what we're doing, but it's important to know we can't do that. So instead, what we have to do is incoming dot equals, and then we have to write the string we want. So we'll say for the red one, we just want to say red. If it equals red, what will we do? Digital right, red, high. So we'll turn on the LED. Easy enough. Then, what are the other options? So there's the other LED, so we can do green. If incoming dot equals, call that green. Digital right, green, high. So now we have this all written out. We'll walk through it real quick. In the loop, so over and over again, first we look to see if there's something inside the serial buffer with this function right here. If there's anything in the serial buffer, we say incoming equals read string. So that means we take what's in the serial buffer and then we put it inside this string called incoming. Next, we check to see what the value of incoming is. And you know what? I just realized something. This is outside this if statement. So what's going to happen is this will happen every time it goes through the loop, but this will happen only every other time. Hey, Future Robert here. Just decided I'd stop everything for a minute to clarify something. It's not that it goes through the if statement every other time through the loop. What I was trying to say is it only goes through the if statement when there's serial data available. So that means that checking to see what incoming equals when there's no new data is kind of pointless because we've already looked at that data and dealt with it. So in this case, we don't want to do that. With that said, I'm going to get out of here and take you back to past Robert, who will continue walking you through the code. So since nothing changes what the incoming value is at the end of the loop, if it was red, it will stay red until something changes it. So what we're going to do is we're going to just take this and put it inside of our loop, it's not a loop, but inside of the if statement. Now, if I highlight everything and push tab, it will then automatically indent everything to the level where it's supposed to be. Indentation is optional in this. However, I think it's a really good idea to see where things are. So this way I can easily see that all of this happens inside of this if statement because of the fact that it's one level further in. All right, so we have this. Now what we need to do is to upload it to our board and then test it. So we have constant red. Oh, see, I made a mistake. I forgot to declare my type. So this is a integer that is called red, and this is an integer that is called green. Now let's try it. And we have a problem uploading to the board, which is because I've disconnected the board. That would explain why it's not working. So hook it back up and try again. We're uploading the sketch. So now that we've uploaded our code, we need to open the serial monitor. And we see there's nothing in there. There's not supposed to be, we're not printing anything to it, so nothing will pop up. But instead, what we're going to do is we're going to type red. See what happens? Nothing happens. Okay, what if we type green? Nothing happens. All right, so now this is where the serial monitor becomes really handy. We know that we're receiving values into the Arduino, but we don't know what those values are. So what we can do is we can use the serial monitor to tell us what is going on. So inside of our loop here, we're doing this. So we're going to put back what we had before. So serial.print line. You just entered. Now, if you remember before, what we did was we had a regular print. We closed this off. We had another line. I'm going to show another way to do that called concatenating. So what we're doing now is we're going to put the plus sign, and then we're going to put incoming. So instead of putting a whole nother line, we're just going to add to these together. It's essentially what it's doing. So it'll take, you just created, put a space, plus, and then our variable. So we will upload it. And once it's done, bring up the serial monitor. Type in red. You just entered red. Okay, so that works, right? Okay, so why didn't this work? We expected it to work, it's not working. It's a really good question. I'm glad I asked it. So to get a better idea of what's actually going on, why don't we switch from using the read string value here to just read. Now remember, what read did is it takes the whatever's inputted and it kicks it out. What read string does is it takes it and it formats it as a string. So this will give us our raw values. We'll know exactly what's happening. So let's take a look at that and see if we can figure out what the issue is. Okay, it's done uploading. Bring our monitor back up. I type red. Okay, so here's our raw values, right? 114, 101, 100, 13. Okay, now what if I type green? 103, 114, 13. So 13 here in both of them. That's kind of interesting. So if I type something just random, like all sorts of letters, 13. It's always ending in 13. Why is it always ending in 13? Well, remember a long time ago when I mentioned that after you type something, if you hit send or push enter, it will send this value right here. 13 is a carriage return. So what's happening is we're sending the value, so we'll clear it out. We hit red. 101, 100. We have to assume this is red, correct? And then 13 is the carriage return. We're asking it if, in our code here, we're asking for the red. There's no 13 in that, which is our carriage return. So what we could do is we could add the value for the carriage return, which is \r, but that's kind of unintuitive and weird, right? So if you think back to when I was talking about this, there's the carriage return thing here. We could just tell it to send something else, right? We could tell it to send a new line, right? So if we do that, type red, so we know 101, 100 is red. 114, 101, 100, 10. 11, 10, 49, 49, 10. Okay? So apparently, new line is 10. Okay? So what if we just sent no line ending? So let's clear that, see what it does. Red. Okay, so now we have 114, 101, 100. Good deal, the 10 is gone. That's what we want, right? Well, our light's still not on. Why didn't it turn on? We're not sending the 10 anymore, so it should match. But you have to remember now, we're not sending red. We're sending 114, 101, 100. And our Arduino doesn't know what to do with that. It's 3 integers. It doesn't care about those. So we need to go back into our code, change it back to read string, upload. Now when we could take out this print line, but let's just leave it. It doesn't really matter. We put in red, and our red light turns on. It's really cool, right? Now what, green? And the green light turns on. That is exactly what we were hoping for. That's really cool. So now, if we look at it, we have no way to turn the light off. What I want you to do is I want you to go and take this code and add into it, when you type in off, both of the lights turn off. So that is your exercise for this video. In our next video, we will be going over sensors and how to use them. And then we will try to tie everything together for a slightly more difficult exercise to accomplish that. Thank you for watching and have a good one.